Can everybody hear me okay down the back? Thumbs up, that's awesome. Hey, so yeah, thanks for having me today. Well, I'm going to share with you some lessons learned over the last couple of years working in big tech and in SRE teams around running reliability in the cloud. I'm hoping to distill some of the things I've learned into like 2 rituals and a couple of ideas that you can hopefully take with you and succeed with the reliability of the products that you are building and the things that you are building. So before we get started on that, first a little about me and my journey. So let's see here. Next button, there we go. All right. A few years back, 2017, last time I spoke to Latency conference, I was working at Channel 7 on some products you may be familiar with, Perth Now, The West, and now 7news.com.au. I helped the team to build out their cloud presence. At that time, all of those websites were based on Yahoo's infrastructure, and 7 West wanted to in-house it and sort of this greenfields project, start from scratch. So a team of developers and a team of ops guys and myself, we built out the new platform from scratch. And when you go there today, you're still running on that new platform on AWS. As Hamish alluded to, from there I moved to Dropbox in the US, where I worked on a bunch of SRE teams. So initially with the async messaging team, who there's about 15 different distributed systems that are responsible for any sort of asynchronous process. So things like toaster pop-ups in your browser, or generating thumbnails when you upload an image. Anything that happens like not in the user request flow. There were a bunch of systems to manage these, and I was the first SRE hire on that, so helped to build out that competency. And then moved from there into what was called the services SRE team, which was kind of like responsible for the main monolith of Dropbox. Like when you go to dropbox.com and you're there in your browser, it's running inside a system called MetaServer, and my team was kind of owned that, and also helped the other SRE teams to build like tools and processes and help kind of bootstrap the whole organization's SRE competency. And then made the move to Facebook, where I was on the ZippyDB team. ZippyDB, you've probably never heard of it, has a very silly name. But it's kind of like DynamoDB, but internal to Facebook. It's one of the biggest data stores at Facebook, as well as the world. And it was a lot of fun. I was a production engineer there, responsible for like establishing SLAs for the system and helping them to meet some really competitive performance targets. From there, Canva, let me see, COVID, not Canva, oh my goodness, let's unassociate those two. Canva, COVID brought me home to Australia, due to sort of circumstances outside my control, and I was very, very fortunate to have an opportunity to join Canva as their first principal engineer, where now I'm a software engineer in the infrastructure team, and helping them to build our SRE from scratch. So we've sort of made our first SRE hires, so helping them to build an SRE hiring pipeline, establish what the practice means, and sort of create processes and tools for all the other service teams to embed reliability into what they're delivering. So you can expect here forward to see like a really good, reliable product from Canva. So you'll hear me say SRE, maybe not everyone's familiar with SRE. What is it? SRE is Site Reliability Engineering. So this is not an SRE talk. This talk is kind of targeted at software engineers and folks working on cloud platforms. And I want to give you the SRE wisdom to go and do so really, really well without having to like make a maximum investment in hiring SREs and all that kind of thing. So what does Site Reliability Engineering mean to me? Well, firstly, it's software engineering. It's a software engineering discipline. We solve problems with code. That's really important. You'll find that SREs come from different backgrounds. There'll be some who come from software engineering backgrounds who are interested in distributed systems and interested in reliability. And you'll also find a lot of folks like myself who like come from an IT operations background, where we've expressed an interest in solving problems with code, and somewhere between those is SREs. It's really important that we build products and not projects. So reliability is not a project. It's something that you need to like plan from the start, and you need to iterate on and own for the entire life cycle of whatever it is you're building. So a good SRE engagement will be with you from the very, very beginning all the way till you turn the lights off on your systems. One of the things that I like most about SRE, and the reason I'm drawn to it, is that it's quite anti-intuitive. So Systems fail in ways that you don't expect, and obvious solutions occasionally make things worse. Some examples of this are like auto-scaling, right? Like auto-scaling seems like a great feature when a system gets congested, we'll just add more hosts automatically, no touching the system, and things should get better. When in reality, about 50% of the time it makes things worse. And it's kind of unintuitive about why that is. Another one would be queues. Like we might have some SQS queues and the queue fills up. So the obvious solution is make a bigger queue. And you might do so and you might learn that you've just created a whole world of pain for yourself. So it is unintuitive, and I find that to be like a big draw card. And lastly, SRE is kind of about pragmatism. Everything is a trade-off. I like to say the most reliable system is a system that's turned off. Like it'll behave exactly the way you expect. But obviously, we need to find a balance, right? So reliability, like a lot of things, is asymptotically expensive. The better you get at it, the harder it is to get to the next step. So we want to find the right investment for your business and for your systems, and make those right trade-offs and understand what's important to your customer. And we'll get into that a lot more. So SRE is software engineering with a dedicated focus to reliability in production. So today's goal is to give you 2 rituals to get started so that you can ignore a lot of the noise around SRE. There is a lot of information. There are volumes of books about this. There are talks all over the place, lots of great information. And if you can't afford to invest in SRE full time, then you probably want to know, like, what is the minimum effective dosage for me? Like, what is the smallest thing I can do to get the maximum effect? And I've made an attempt here to do that for you. So I'm going to give you a little bit of a prescription. I should say this is not a scientific approach. I haven't gone and done research and surveys and tried things over time. This is kind of distilled wisdom from all the things I've learned from my peers and from working on this for the last couple of years, and hopefully it's helpful to you. And the last thing we're going to do after talking about these 2 rituals is just look at some anti-patterns that I see that perhaps you are guilty of, and hopefully I can shine a little bit of light on it and it might make life easier for you. I'll just pick that up. Okay, so, excuse me. What do I mean by reliability, and why is it important to you? Why should you care? So reliability is not invulnerability. It's more like predictability. Raise your hand if you would say that you have a reliable car. Right. Keep your hand raised if your car keeps working when it runs out of fuel. There's got to be some EV enthusiasts going. So your car is not reliable at all. In fact, it has a bunch of failure modes, and it's resilient to none of them. It can't route around most failures. And if you don't service and put fuel in your car, it's just going to stop working no matter how fancy it is, or if you don't charge it. But this is predictable. You know this when you buy the car. You understand its limitations. And therefore, like, if the car behaves within those limitations, within your expectations, you'll put your hand up and say, yeah, I've got a reliable vehicle. I like it, right? So that's what we're aiming for here. When I say reliability, I'm not saying that this thing is bulletproof and it never stops no matter what. It's not a Toyota Hilux. What I'm saying is we need to create a very clear narrative around our systems and our services that your customers understand, so their expectations are right, and so we meet those expectations. An example of this is like device reboots. Everyone knows you've got to reboot your phone every now and then, and maybe you get annoyed when it happens, but like, you don't take it back to the manufacturer, right? Because you know this is a thing that happens, I'm okay with this. So reliability, conversely, I'll talk about resilience. Resilience is that property. Resilience is the property to withstand unusual conditions. So I ran out of fuel, the car keeps working, that's resilience, right? So our reliability story is 1 part resilience, 1 part performance, and 2 parts communication. It's all about setting those customer expectations. It's okay, in fact it's inevitable, to have routine failure in your cloud systems. So the 2 rituals are going to fall into 2 categories. One is we want proactive and reactive rituals. So one, we're going to react when something goes wrong in our system, and we're going to have a process for that. And the other is proactive, that we're going to have like a routine cadence practice that's going to prevent incidents from happening and make our systems better with time. Let's start with the reactive process, and that is post-incident review, also known as postmortems. This is probably nothing new to you. I'm sure you've heard of these. Like I said, the point of this talk is not to introduce you to something new, but instead to sort of say, of all the information that's out there, where should I start? So I'm interested to know, can I see a show of hands like people who've participated in a post-mortem or a post-incident response? Yeah, cool. So they're like pretty well established, and if you haven't been in one, I'm sure you've heard of them. So the post-incident, for those who haven't heard of it, or the post-mortem, is just a time box meeting that happens after every incident, or maybe you can group a bunch of incidents into one meeting, where we review what happened and try and learn as an organization from what happened so that it doesn't happen again. Now, when I say like this is a good place to start, I have it on really good authority, and I'm going to give you an appeal to authority argument here. I had a conversation recently with Niall Murphy, who is one of the founding people of SRE as a practice. He was there at Amazon and Google and now Microsoft. And he said, if you do nothing else, start with incident review. So I want to reiterate that to you. I asked him if I could quote it, and he said yes. So you have it both from my wisdom and from the great Niall Murphy, that post-incident is a really good place to start. So why? What is the goal of post-incidents? Let's see. So number one, we want to prevent recurrence. When an incident happens, when something fails, we want to make sure that same thing doesn't happen again. We want to prevent this incident. So our document service went down because it ran out of disk space. Let's stop disk space being an issue for the document service. More importantly, is how do we prevent incidents like this? So we might want to say, well, any system can run out of disk space, so we need early warning on this, we need automation to clean up useless data on those disks. We want to prevent incidents like this. And ultimately, we want to move towards what's called an anti-fragile system, and I'll talk about this a little bit more in a second. So the way we do this, the way we prevent these incidents from recurring, is by learning and adapting. When I say learning, I'm going to say it a few times. I don't just mean you learning and you going, oh, I understand this now. I mean like the system, your team, the organization, the incident process itself, as well as you as an individual, learning and adapting, like incorporating the information that you learned from this incident so that the system and the processes are better because of it. So anti-fragile is a concept you may be familiar with. It's a book by Nassim Nicholas Taleb, and it talks about systems that gain from disorder. So every incident should make the system and the business more resilient to failure. A great example of an anti-fragile system is your muscles. So when you do a workout, you're actually ripping and tearing a lot of the small fibers in your muscles, but the healing process that happens afterwards is what increases your strength and you get gains, right? Like it makes the mass larger. And we want our incidents to be similar to this. We want to make sure every time there's an incident that there's little tears that our system's muscles get bigger, right? So post-incident review is a way to improve the system and the processes and the skills of your engineers. So what should this meeting look like? You'll want to meet probably weekly, maybe monthly. Depends how often incidents occur for your company. You can do these with the team who owns a service. Depending how big the company is or the org, you might want to do this with your organization, your group, or you may want to do this with the whole company. We at Canva do this pretty much with the whole company. So the biggest incidents of the week will be in the weekly review. At the end of the week, we just pick sort of the 2 or 3 worst ones because there's more than 2 or 3 in a big company. And we want to make this time bound. We keep it to an hour. We want to try and stay out of the weeds a little bit. Don't go too deep on like solving technical problems. That can happen offline. You really want to keep this meeting focused on improvement of the process and system, like the what you're going to do, not how you're going to do it or what it'll look like. But that said, like lean into your team dynamic a little bit. So if the team in the room tend to go into the weeds on the tech and it looks like they're going to get somewhere and produce some good outcomes, kind of let it happen. Or maybe they focus totally on the process and how they responded to the incident, how they did on-call. That's okay. Like lean into the dynamic of your team. So the agenda for the meeting, we're going to start with a replay of the incident. talk through the timeline of what happened, cover the failure, like when the failure started, not when you detected it, but when it actually started in production. Talk through how it was detected, how you responded, and how you recovered. Clarify everything with metrics, like metrics. I've been in so many post-incident reviews where someone will say, yeah, the web server went down and the database crashed. I'm like, what do you mean by this? Like, what does it mean it went down? Was it thread exhaustion? Was it CPU utilization? What exactly does it mean, so that we can have a scientific conversation about how to fix it? We're going to talk to, in your agenda, talk to contributing factors. Some people will say root cause. I'm going to talk about this some more. There is no root cause, right? There are contributing factors. There are multiple root causes always, and we don't want to like hone in on one. Oh, and pay attention to both the system, the compute and the software, as well as the process. How do you do on-call? How do you do alerts? How do you respond during an incident? How do you communicate? How do you collaborate? And lastly, you want to produce some action items. So let's dive into, firstly, the contributing factors. You may have heard of the 5 whys is an interesting way to find the root cause for something. And it kind of goes like this. You'll ask, state what happened, then ask why. Answer that question, then ask why. Answer that question, ask why, and you'll do this 5 times. And it's trying to like trigger some critical thinking to get you to go a little bit deeper. And it's good as a tool to provoke critical thinking, but it's terrible as a tool for analysis, right? So it looks like this. My car didn't start. Why? Well, there's no fuel. Why? I didn't put fuel in when the light came on. Why? I was tight for cash. Why? I lost my job. Why? Because I want to be a movie star. This doesn't help you fix your car, right? So it's a useful prompt, but it doesn't negate critical thinking. So we want to avoid linear investigation. It's almost never one cause. And you want to repeat this process of asking why, like when you find a problem, ask why, take it to the next step. And it might have 2 different answers or 3 different answers, and follow each of those. It's not linear. And keep doing this until you find causes and contributing factors that aren't actionable. For example, this incident happened because, I don't know, I was really tired. It's not necessarily actionable. We can't institute some process or automation to fix Ryan being tired. I don't know. So contributing factors help us to decide where to invest energy over the long term. So these will typically be either something that triggered the incident or a factor that compounded the incident. And they will typically fall into one of these categories. Software bugs, these typically manifest after a deployment. So you deploy the code, it passes all the tests, everything looks good, but then later on we find out there's some edge case that we hadn't considered and things start bleeding and we find it's a software bug. Config changes also look like feature flag changes or auto-scaling changes. Configuration pushes would typically manifest straight away. Software releases and deployments, hopefully they make sense. Sometimes they pass the test, but you hit prod and everything bleeds, so you've got to wind it back. Operator error, we're going to talk a little bit about blameless culture, but operators do make errors, so we need to ensure controls are in place, that we have the right automation and tools in place to prevent operator error from being a disaster. And capacity is the situation where something is exhausted. We ran out of CPU, we ran out of disk. Auto-scaling lives here. If auto-scaling doesn't keep up with demand or downscales, that's a capacity error. And load changes are capacity problems. If you suddenly have an influx from a marketing campaign, you've got all this traffic that's coming in and you didn't keep up, that's a capacity error. You should have had capacity in place ahead of time for that situation. And lastly, third-party outages. This is the one that surprises everybody all the time. We're almost never prepared for this. I see situations where AWS will have an AZ failure, or Google Maps API will be down, and everything goes down. So we want to pay attention to these contributing factors and track them over time and decide where to invest our energy. Action items from the PIR, we want to keep these SMART. If you're not familiar with the acronym, like specific, measurable, achievable, relevant, and time-bound. You can look up SMART later on, but we want to make sure that these things are not vague, that they're very, very clear. And our action items should focus on a few different parts of the incident. The prevention of the incident happening again, action items to improve our detection of an incident, action items to to improve our response, and lastly, our mitigation, so how we stem the bleeding and keep production up and running. All right, I said we need to keep it blameless. I'm sure you've heard about this. Human error happens. Humans learn from their mistakes. Machines and processes don't. So don't waste your time trying to teach human beings stuff in a post-incident review meeting. They'll learn that for themselves. It's the system and the processes that can't. So we need to give that time to them and be genuine about it. We want to build a culture where it's safe to fail. So to the executives in the room, post-incident review is not a forum for accountability or discipline. It's very easy to ruin the culture so that people aren't very honest. And to give an example from my own career, many years ago, not in one of these companies, I was on a Windows server in an RDP session, and I was clicking around on stuff. And I don't know if you remember, like 2003 era, Windows Server 2003, a little pop-up came up saying, this machine has applied some updates. Do you want to restart now? And I went to click on the thing that I wanted to click on, and the pop-up went, hey! And I clicked yes, without meaning to. This all happened in a fraction of a second that seemed like a lifetime. And the server went down, right? It was the email server for the company. They had one email server. And I was honest about what happened. I said, yeah, look, this thing popped up. I didn't get it before my brain even knew what happened. I'd clicked it. And I got a written warning, which was not cool at all. And the result of this was that we didn't actually spend any time fixing the problem, that we don't have redundant email servers, that we're using RDP to click around on stuff. We don't have any automation to take care of these processes. So the problem never got fixed. And instead, what happened was myself and the people who saw what happened to me were a lot more quiet about their mistakes. And there were a whole bunch of other problems that didn't get fixed. So don't mess it up. Be genuine about making this blameless. Focus on improving the system and the process. Lastly, for the incidents, play the long game. Don't expect miracles from one meeting. It's going to take time and compound interest. Just keep building on what you've got. And track them over time. Track some different metrics for your incidents, like your time to detect, the time to recover, the list of things up there, not root causes, contributing factors. And you should see these things improve over time. Now, the second ritual is a proactive ritual. We're going to call this Operational Metrics Review. It's another meeting. I'm sorry about the meetings, but I am trying to keep this to the smallest possible investment for maximum return. It's a weekly meeting with each service team. So teams can run these independently, and probably the people in the room would be like one team or one on-call rotation. And we're going to use this meeting to track some key metrics, and we'll go into some important metrics here. But why is this meeting important? We want to prevent incidents before they happen. So we're going to prevent new incidents. And in this meeting, we'll make sure that our action items from our post-mortems get delivered. We're going to keep our finger on the pulse and track those week to week. We want to identify blips in our system, like with capacity or CPU or errors, to prevent them from becoming failures, right? Total outages. Most incidents I've ever seen were kind of predictable ahead of time. Capacity was running out, we didn't know, we didn't action it, things blew up. Validate our automation is correct. So this is things like we have automation in place to prevent incidents. Great example of this, I'll talk about a lot, is auto-scaling. Validate the auto-scaling is correct. Have a look each week and go, did auto-scaling save us this week? Did it behave the way we expected? Did the system scale how we expected? And lastly, we want to validate our capacity plan and say, are we using as much compute as we think we are? Are we using as much storage as we think we are? How we do this through the meetings is through continuous improvement. So, and by continuous improvement, I mean specifically the improvement kata from Mike Rother. But I'm going to give you an improvement kata here for reliability that we can exercise through these meetings. The process here is a repetitive one. We scope the challenge that we're trying to solve, quantify the current condition, establish the target condition, and then experiment and iterate until we get there. This process actually underpins DevOps. If you've read the DevOps material, this is quoted a lot in that material. It comes out of the Toyota production system. What I like about this kata is, kata being like a practice. a lot of people will look at the Toyota production system or look at DevOps or look at Agile and how they do it at Spotify or how they do it here or there. And we kind of look at the artifacts of that. And we say, oh, they do daily stand-ups. I've got to do daily stand-ups. Or they do this meeting. I've got to do that meeting. But what this kind of misses is how they got there. Like, how did these companies like Toyota get to such an excellent manufacturing process? And that's what Mike Roth has tried to distill down to a practice, which is this repetitive cycle called the improvement kata. So, scope the challenge. There's going to be a quiz. Quantify the current condition. Establish the target condition. Experiment and iterate. Let's go over an example. Example, on-call is too noisy. We've all been there, right? So what's step one? Yep, scope the challenge. So let's scope the challenge. Why does this matter? Why does it matter if on-call is too noisy? Let's just, like, in our ops review meeting, write this down. We want to fix on-call, it's too noisy. Why does this matter? Because exhausted engineers make more mistakes, and it leaves us less time for production development. There's probably other reasons, but, like, let's use this as an example. Where do we want to go? We want to get to a place where on-call is not noisy. So, what's step two? Quantify the current situation. So this is about getting metrics. Like, let's get some data to prove that we have a problem. How many alerts are we receiving? What actions are we taking based on those alerts? Are they actionable? Do we have to keep doing the same thing over and over again? And what are the repeat alerts? Like, are we seeing constant alerts for CPU or constant alerts for error rate? Let's get some data. And step three was to establish the target condition. So where do we want to go specifically? We want to get to, let's say, less than 5 out-of-hours alerts per on-call shift. Something specific. It doesn't have to be a perfect number, but just an arbitrary number that's better than where you are today. And maybe we want to get to 90% actionable alerts, so that when we get woken up at night, only 10% of the time is it something inactionable. So the next step here, step 4, is to experiment and iterate until it's done. So we want to use the ops review meeting as dedicated time for this practice, for establishing metrics, quantifying where we are right now, quantifying where we want to go, and then iterating weekly until we get there and reflecting on those metrics. More than this in the meeting, we actually also want to, like, create visibility and accountability for the things that we care about. So if we're trying to improve on-call and make it less noisy, and we're talking about it every week and the whole team is in the room, it's going to, like, trigger their subconscious. They're going to be thinking about it. They're going to make decisions independently from you that are going to help towards that goal. Kind of like how stand-ups work, right? It's just there's a repeat cadence of accountability and context sharing. This is the same thing, but for your reliability goals. A little nod here to my man, the Doom guy. Rip and tear until it's done. Let's continuously improve until it's done. So what was step 5? There was no step 5. All right. So scope the challenge in your ops reviews. Scope the thing that you're trying to solve. What are we trying to solve? Quantify the current condition with metrics. It needs to be measurable. Establish where you want to go with those same metrics, and then experiment and iterate weekly through those meetings until you get there. Quick look at what the agenda might look like for this meeting. What should the agenda look like specifically? To quote every senior engineer ever, it depends. It will really depend on what the goals are for your team, what those metrics are that you specify. Is your on-call on fire? Then you're going to want to track on-call through the agenda here. But there are some must-haves. Let's go over quickly at a high level. So metrics that matter, these are those continuous improvement metrics. They should include your SLOs. Track your SLOs and your violations against those, your service level objectives. I could do a whole other 10 talk series on SLOs, but hopefully you'll look those up if you're not familiar with them. Track your capacity risks, the improvement projects that you're working on, and system dependencies. Pay attention to how other services and your databases and other middle tier layers are behaving for your service, things that you depend on. Third-party integrations. Pay attention to on-call and toil, how much time you spend responding to problems. Review your on-call shift, like get them to give a summary. Everything was great, it was really terrible, I had 10 incidents at the same time. We want to know and surface that. Also pay attention to your alerts. Are your alerts going up or down? We want to get that noise down. We want to reduce noise, reduce toil, and promote practice and muscle memory, right? Like we want the team to be not figuring out what to do during an incident, but we want them to be comfortable with it and know how to react. And this is a good place to build that muscle memory. Pay attention to your releases. Put some time aside to review, your deployments for the week, and how did they impact customers? Did everything go to plan? Did anything go wrong? What changes do we have coming up that we need to pay attention to? And of course, use this as a way to improve your incident posture. So track your action items, make sure they're getting delivered, review your run books. Are they still relevant? Is the documentation up to date? Are they helpful during an incident? And then prepare for any PIRs that are coming up. If you've got a post-mortem coming up, make sure you and the team get together, you're all on the same page, you've got a consistent, clear story about what happened. Cool. Let's have a quick look at some of those key metrics that might matter. Some of the things we might want to improve over the term of our continuous improvement process. SLOs, noted these, service level objectives. These should map to your customer experience. Customer is king. A lot of folks are probably familiar with like the golden signals that come out of SRE, so latency, throughput, error rate. These are really, really important metrics to track as service level objectives that map to your customer experience. But they only work for like a subset of things, particularly like stateless services. So what about things like streaming APIs or async APIs, like generating thumbnails or exporting media files? Customers care about more than just availability and throughput. They also care about things like backup and restore, like how much data can you lose from your database. They care about durability. When I go to retrieve my file, is it gonna be there? So pay attention to what your customer cares about. Capacity. Lastly, on this is service desk tickets, right? Like track your service desk tickets. If you've got a service desk, make sure you're paying attention to what your customers are complaining about. It's a proxy metric for what's going on in your system in terms of like quantifying it, but it's a really important signal on how your customers feel about your service. So capacity here, things that we're going to care about, you probably can name pretty easily, is like CPU, memory, disk I/O, disk allocation, but pay attention to some of the things that are going to hurt you during incidents. Normally when I see incidents, there's plenty of CPU incidents, but it's things like throttling or burst credits. Your underlying cloud provider, they give you allocations of resources over time, and they tend to run out if you're not paying attention. So track your usage of your quotas, particularly for third-party APIs. Third-party API incidents are the absolute worst. I've been there a bunch of times where we query GitHub for something as part of our deploy process. GitHub rate limit you, and now you can't deploy that hotfix that's like going to stop your customers from bleeding. And what can you do about it? Literally nothing. There's nothing you can do about it. You just have to sit on your hands and pray until the problem goes away, unless you have like a direct line to someone at GitHub who can unblock you. So pay attention to your quotas. Alerts and interrupts, we kind of talked through. Pay attention to how many alerts are coming through, how often your engineers are interrupted with requests for help. The action item burn down, and then migrations. What I mean here by migrations is commonly you'll have projects where you're like moving from version 1 to version 2 over a couple of months. Use the ops meeting as a way to track that. Again, play the long game here. When you institute these meetings, they're probably going to suck for the first couple of months, but then you'll start to see the gains. This is a compound interest problem. We're going to build the system up, get it to a new level. It's going to unlock new opportunities. It's going to unlock new capabilities. Then we're going to build on those. And this just keeps happening until you get really, really good. This is the whole point of the kata. The kata is like, it's not the artifacts of those processes and tools. It's not the stand-ups or the meetings that they produce or the tools or the fact that they use Jira. That's not what makes them successful. It's how they got there. It's how they built up that muscle over time to produce these artifacts. So, invest for the long term. Let me see. I've got a few minutes left, so I want to talk through. I want to talk through some anti-patterns. These are the two routines that I want you to participate in. One is post-incident review. If you can only do one of these things, start with that. When something goes wrong, pay attention, organize around it, and learn from it and adapt from it. Number 2 is the ops review meetings as a way to prevent incidents and proactively build muscle and build capability around reliability of your products so that your customers' expectations are met. All right. So some anti-patterns and some reliability traps that I see at lots of cloud organizations, in no particular order. These are just riffing. But for you particularly, keep an eye on your post-incident reports and your ops reviews for these anti-patterns. Like these might show up for you. In fact, hopefully I'm right about this, I'd almost bet that they'll show up in your incident reviews. So number one is no customer happiness metrics. I see this all the time. Like, we get alerts for CPU, we get alerts for disk space, but we don't get alerts when errors are happening for customers. Plays out a lot in incidents. So the golden signals I talked to, they're pretty well tracked, but it's the bits around the edge, like quotas on third-party APIs, or streaming. You know, like if you're streaming data to a user, there's no point at which an error is generated, and it's hard to figure out how to measure latency. So you've got to figure out, how do I measure customer happiness here? And it should be the number one thing that you alert on. Honestly, if you alert on customer happiness, if you alert on an SLO, all your other alerts become way less valuable, and you can probably stop using them outside of business hours. If you've got good signal on when your customers are happy and when they're not, the rest becomes so much easier. Your customers do not care how much CPU you are using. They don't care. Cool. So the consequences of this situation is that during an incident, the impact is unknown. I was in an incident like this recently. Something failed. We knew it had failed, and the question was, how many customers are impacted by this? And we couldn't answer the question for quite some time. It should be the first question you ask during an incident, scoping the incident. How many customers are impacted by this? How bad is it? And it should be the easiest question to answer. So please make sure you can answer this question in every team that you're on. This isn't just your customers, your business customers. This is the people using your service. If you're on a database team running a database, the service teams who depend on your database, they are your customers. You need to know whether they're happy or not. To quote Peter Drucker, one of the management icons, I suppose, in the industry, if you can't measure it, you can't improve it. If you can't measure your customer experience and reliability, you can't improve it. All right. Anti-pattern number 2, under-resourced on-call. Your engineers should be spending no more than 1/6 of their time on call. And this is a scientific measure. There's lots of research. I should have cited it. Ping me about it and I'll send it to you. The upper bound here is 1/6. If they're spending any more than 1 in every 6 weeks or 1 in every 6 months or days or whatever on call, the effectiveness of your on call is going to plummet. I've seen situations where teams only have like 2 people on call on the rotation. They're on call every second week. Not only is this like not effective, because those guys are going to be like not on the ball, but it's plain old disrespectful. Like, how many birthdays and Christmases and events are these guys going to have to carry a laptop along to because they care enough about the system that they're running? So if you've only got 2 people on the team, merge the teams into a bigger on-call rotation. Maybe get these, a bunch of small teams sitting together till you've got 6 to 8 people so that they can run it in production. And if the system is not important enough to do that, if the system is not important enough that you want to pull 6 people in and get them all to learn the system, then it's not important enough to be on call for, right? It's definitely not important enough to ask someone to be on call every second week for. Next anti-pattern I see is solution-driven architecture, where instead of asking the question, like, what problem do I want to solve, we tend to ask the question, what product do I want to use? And we take big products off the shelf to solve small problems. An example of this that I see pretty common, or one that like stands out to me, is we might say, I have this problem. I want to deploy into production my software package. And I want to do it in an immutable image that can't be changed, that contains all of my dependencies. That's the problem I want to solve. And because I want this, I'm going to deploy Kubernetes, right? Now, or ECS, or some container orchestration engine. Now, that will solve this problem, but it's going to come with hundreds of other problems, and it is, I promise you, going to cause you all sorts of incidents while you learn how to integrate that new system into your business. So I'm not saying you shouldn't do that, but I'm saying you should do it knowingly, right? And ask the question, what is the problem we're trying to solve? And what's the smallest, what's the MVP? What's something I can do to get immutable images deployed into production? And man, you can write a script to do that, right? Like you could build it in a month or two and it would be reliable. It wouldn't be as feature filled, but maybe that's what you need. So it's about not reaching for products and instead saying, what's the problem I want to solve? How do I want to solve it? And then, do I want to build this? Do I want to buy this? Do I want to go open source? Do I want to, engage with a vendor? These are legitimate answers, but it's asking the right question. Another anti-pattern I see a lot, or everywhere, is scaling before isolating. What do I mean by this? We have an incident, we've run out of disk space, so we auto-scale, we add way more hosts. Cool, but it's not going to solve the problem most of the time. What we actually need is isolation, and what do I mean by isolation? Usually this looks like a queue data structure or a thread pool in your program. Let me give an example. Let's say you've got a widget server, and 99% of your requests are get widget, right? It's just a little RPC call. They say, I want to get something, so you select it from the database, you return it. It's really fast, it's really reliable. But there's also another RPC called find widget. And when someone calls find widget, it has to go and do a scan over the table in the database, and it's really, really slow. If that find widget RPC starts failing, or the latency starts exploding, the whole system explodes, right? Like people are sending get widget requests that can't be serviced because the system is so busy on these broken find widget requests. So one solution is to scale up the system. Let's just add 100 times as many servers, and hopefully we'll be able to keep up with the traffic. The math on this says you're probably wrong. No matter how many servers you add, it will probably keep breaking. So you want to isolate those requests. We want to isolate the find widget request. And this looks like a queue in your software. So any web RPC that you're using, like Node.js, has a queue. Every request goes into the queue, and then it gets dequeued into the event loop. You want to implement this yourself. It'll take a couple of lines of code. It's probably a little bit unfamiliar, but you want to build queues of your own and say, any requests that's short and easy to service goes into this queue. The find widget requests, these particular difficult ones, I want to isolate them into a different queue. The reason is, if that queue fills up, the find widget requests, it fills up because they're not being serviced quickly enough. When you go to and queue a new find widget request, you just say, queue's full, I'm going to fail early on this request. So everyone trying to do a find widget is going to get a failure, but everyone trying to do a get widget, that queue's not full. The get widget queue, it's still moving forward, right? So we've isolated the failure of those RPC requests from each other. This is far, far, far more effective at preventing failure in your system. So please do some research on this, play around with it, build your own little queues and thread pools to try and solve problems this way, rather than reaching straight away for upscaling. All right, coming up on time, but the other one is under provisioning. Make sure you have enough quota, make sure you're not relying on burst. You've got enough CPU, you've got enough database, you've got enough quota from your third-party APIs. Don't use cheap storage for your databases. Invest in the right storage. Make sure you can lose an availability zone. Make sure you can lose 2 or 3 hosts without having to rely on emergency reactions. And the last one, throwback to 2017, is talking about timeouts, horrific timeouts. Most default timeouts will cause you incidents. You need to get your timeouts down to around P99.9 latency. Some small fraction of your requests should always just be failing on a timeout. Please look up Little's Law, L-I-T-T-L-E, Little's Law. It's going to help you to understand how timeouts can be used as an isolation strategy when latencies start to grow in your system. So some particular requests using way too much latency, the timeouts are going to prevent those requests from using all of your system resources so that other requests can still succeed. All right, reliability, wrapping up, is not invulnerability. It's more like predictability for your customers. How do we get there? We want to tune the processes and tools for your business, starting with 2 rituals. 1, post-incident review. If you do nothing else, do this. Learn as an organization, learn as a team. The system should learn, the process should learn. It's reactive. Ops review meetings, prevent incidents, engage in continuous improvement, and be proactive. And with that, Thank you very much.